Hi, I'm Professor Darryl Thelen of the Department of Mechanical Engineering at the University of Wisconsin-Madison. I'm here today to talk to you about a new technology to measure human body kinetics. This is a technology that we believe could revolutionize the ability to understand and improve recovery, rehabilitation, and performance in sports. Many, if not most, athletes will have some form of injury in their careers. And at all levels, lost time is lost achievement, and at the high levels, lost time is a lot of lost money for the athlete and their organization. Once an injury occurs and acute treatment is done, there are challenges in managing this athlete for the future. How should their therapy be optimized to maximize their recovery and minimize the time it takes? And how can the decision to return to sport be made? How strong should they be? How symmetric their movements? How coordinated? There are pitfalls in the effort to minimize those losses. Training too hard or returning too early can risk re-injury. Training too little or returning later than necessary loses productive time. The solution we are bringing to market is a new technology that can provide objective information about the forces produced by muscles during movement. This technology is non-invasive and it can be used to track the progress of recovery and rehabilitation, providing crucial data to support decisions such as how hard to train and when to return to competition. Tendon tensiometry is not just for tendons. It can detect changes in loading that might occur due to injury in muscle, ligament, tendon, or bone tissues. The technology underpinning tendon tensiometry is based on tracking the motion of waves induced in a tendon by a miniature tapper device. The tapper introduces a microscopic wave which travels along the tendon and is picked up by two accelerometers on the skin over the tendon. The time it takes for the wave to travel between the accelerometers reveals the wave speed, which depends directly on the tension in the tendon. Think of it like plucking a guitar string. The tighter the tension in the guitar string, the higher the frequency and the higher pitch sound that you'll hear. To measure dynamic movement, the tendon is tapped 100 times every second to generate a high-fidelity record of how the tendon is loaded over time. Some common activities are shown on the screen. On the top is running at different cadences. You can see how the patellar tendon wave speed changes. And in the bottom, you can see how the Achilles tendon loading changes as you walk faster. And now my colleague, Professor Peter Adamczyk, is going to come in and talk to you more about its use in rehabilitation.
I'm Professor Peter Adamczyk, also of Mechanical Engineering at the University of Wisconsin-Madison. The vision for tendon tensiometry begins with an injured athlete, for example, an ACL tear. Following surgery, this athlete will have 6 to 12 months of rehabilitation, and where she falls in that range may determine the difference between winning a championship and losing a season. This athlete wears tendon tensiometers during training and rehabilitation and gets feedback from a coach or a physical therapist on how hard she should push and when she should advance. Here on the right, we see a cartoon of what that therapist's dashboard might look like. A record of the individual's performance, such as asymmetry or a comparison to normative data, or to her own past performance. And here in the lower corner, some summary metrics, like comparison to a sample of similar performing peers, or the extent of recovery compared to her target. Even in healthy athletes, tendon tensiometry can help improve performance and potentially avoid injury. For example, perhaps asymmetry is a sign of impending risk or a detriment to a player's performance. In this case, this player may wear tendon tensiometry during training or even during practices and get a readout of how asymmetrical their movements are. A strength coach could listen to their feedback and watch their performance on these metrics and give them particular exercises that improve that symmetry to ultimately improve the way they play. Because sports injuries occur at all levels, the market for tendon tensiometry is fairly large. Just in the United States, there are over 160 professional sports teams. There are also over 500 NCAA Division I and II colleges and a variety of elite youth sports and high schools that all could use this information. If we consider even just two of the most common sports injuries, ACL tears and Achilles tendon ruptures, those account for over 330,000 injuries per year in the United States at a healthcare cost of billions. If we could reduce through tendon tensiometry even a fraction of these injuries, the benefits to society would be immense. Tendon tensiometry fills a void in the space of analytics for sports performance. On the one hand, motion capture labs produce very comprehensive biomechanical data, but they're very expensive to set up and to staff. Even interpreting the data from them requires expertise on an ongoing basis. On the other hand, wearable sensors, like accelerometers, inertial measurement units, and electromyography, can be taken out into the field, but they don't even measure loads on the body, and these loads can only be deduced through complex modeling. Tensiometry fits into the middle of that range and fills a gap where it measures directly the loads on the body while also being able to go out into field-based environments and measure an athlete while they do the movements that are directly relevant to their performance. So how do we get traction for tendon tensiometry in the marketplace? Well, we've patented the technology, and we've garnered over $2 million in support for commercialization efforts through NIH small business tech transfer mechanisms and commercialization support through WARF. We've also gathered several testing partners to help understand how tendon tensiometry fits into treatment of different problems that might arise. Gillette Children's Hospital is studying with us how tendon tensiometry can inform the way they treat children with cerebral palsy. The University of Pennsylvania is studying how people recover from tendon rupture in their Achilles tendon. Harvard University is using it to optimize the performance of exosuits and exoskeletons. And our RNUW Athletics is helping understand sports rehabilitation. I'll hand it back to Darryl to talk about why our team is the perfect one to perform commercialization on this technology and how you can help.
Thank you, Peter. So why is our team set up for success in translating this technology into commercialization? First of all, we're the inventors of the technology. The system was developed in my lab as a lab-based system, and then working with Professor Peter Adamczyk, we have translated it into a wearable system that can be used in the field for sports applications. We also have domain expertise in biomechanics. Personally, I have a long history of working in ACL reconstruction, pediatric gait disorders, and musculoskeletal biomechanics, and Professor Adamczyk brings expertise in wearable sensors and wearable prosthetic devices. So what we are asking for today is your help in gaining access to the potential users of this technology to pilot test it and help us target specific value-realizing use cases. We want to talk with individuals who might value the measurement of loads inside the body, who can tell us exactly what forms of information they would use to make decisions, and how making those decisions better brings value to their organization. Ideal contacts would be elite athletes who want to understand better how their bodies are working, their coaches and trainers who could act on this information to improve health and performance, and sports medicine doctors and physical therapists who could make medical decisions based on it. And we also need help in the business and entrepreneurial aspects of this, particularly in the fields of rehabilitation, sports medicine, performance, wearables, and cloud services. And so we invite you to contact us to help launch this new era in wearable movement kinetics, the future of healthier sports.